Welcome to Chapter 4, Section 4.2. We're going to talk about conversions within the metric system. And we're going to look at the three ways to convert units within the metric system. The first one's going to be moving the decimal point, as most of you already know. And then we're also going to look at the two different methods. You can see they're on the board there. The ratio proportion method, and then also the dimensional analysis method to solving for the variable. When we're looking at the ratio proportion method, this is the one that we've already gone through. We'll see that the most important difference between the two is that the ratio proportion method is going to have a specific spot for the variable where you'll solve for x and isolate x, whereas the dimensional analysis method, you're just going to basically make sure that the item that you're converting, in this case we're converting 486 milligrams to grams, that will be on its own, and you're going to multiply that by, we know that there's 1,000 milligrams per gram. Most important thing to keep in mind with the dimensional analysis method is that the units of measure on the bottom are going to be the same as the one that you're multiplying by. So instead of having its own spot for the variable, what you're going to do is cancel these two out, and then you're going to multiply this by this, which would be 486, and then you can divide by your denominator. So let's take a look at some of the problems from the problem set on page 85. The first one, number 1, we're going to convert the following units within the metric system by using the ratio proportion method, and retain all significant figures and do not round the answers. So the first one, 1964 micrograms, and we're going to convert that to milligrams. Okay, so our variable is going to be the milligrams, so that's going to be x over what we know, micrograms. So since we've got micrograms on the bottom, we're going to have to keep micrograms on the bottom over here, and milligrams on the top over here. So we know that 1 milligram is equal to 1,000 micrograms. So over here, we're going to put 1964 micrograms on the top, multiply by that. These two are going to cancel each other out. So we're also going to multiply by that over here. The milligrams, or rather the micrograms, sorry, are going to cancel each other out. So we will take 1964 divided by 1,000. X is isolated, so we can actually rewrite that so it's a little clearer over here. So 1964 divided by 1,000, and x is going to equal 1.964. And remember, it says retain all significant figures, so we're going to leave it like that. Don't forget to put your unit of measure on the end. All right, let's look at number 2, 418 milligrams. And we're going to be converting that to grams. So our variable is going to be grams over what we know already. And 1 gram is equal to 1,000 milligrams. So we're going to multiply by 418 milligrams up here. This cancels these two out. We're going to do the same thing over here. The milligrams are going to cancel out. We can rewrite it so it's clearer. 418 times 1 is 418 over 1,000. If we take our numerator, divide it by our denominator, that is going to give us 0.418, and our unit of measure is grams. Okay, let's look at the other side, converting the following units within the metric system using the dimensional analysis method. So we're still solving for the same thing, we're just using the different method of doing it. Retain all significant figures and do not round the answers. So let's look at number 11. 52 milliliters, and we're going to convert that to liters. So our known is 52 milliliters times 1 liter in 1,000 milliliters. And remember, your denominator is always going to have the same unit of measure as what's going to be on the left side over here. So these two are going to cancel out and you'll multiply 52 up here. So 52 divided by 1,000, and x is going to equal 0.052, and our unit of measure is liters. They're both going to get you the same answer. You can use the dimensional analysis method. You can use the ratio proportion method. It's really just a personal preference. The book just wants to teach you both ways, so you'll understand how to do it. Number 12, 2.06 grams converted to milligrams. So we've got 2.06 grams times 100 milligrams over a gram. Now the reason it's flipped again is because this unit of measure is grams, so we want to make sure that we have grams on the bottom as well. So these are going to cancel out and you're going to multiply by that and then divide. So x is going to equal 2,060 milligrams. Now of course you can still, if you'd like to move your decimal, you're welcome to do that if you're comfortable doing that. That's the topic that we didn't cover because most of you have already gone through that in previous math courses. If you turn the page to number 86, or page 86, let's look at number 41, some of the actual application looking at pharmacy prescriptions. Okay, the following prescription has come into the pharmacy: clarithromycin granules, and that's 125 milligrams per 5 ml. And the directions are 2 teaspoons, twice daily with food for 7 days. Okay, first question, letter A, how many milliliters will the patient take daily? Well, they're taking 2 teaspoons. We know each teaspoon has 5 ml. 5 ml times 2 is 10. We're not done yet though, because they're going to take that twice a day. So we're going to take that times 2. So they're going to take 20 milliliters a day. How many milliliters should be dispensed for the patient? Well, we know how much they're taking a day, and the full dosing cycle is 7 days. So 20 times 7, that's going to be 140 milliliters for the full dose. How many grams will the patient take daily? Well, they're taking 20 milliliters. So we can set up our proportion. We're looking for grams, but right now our prescription's written in milligrams. We can convert it. We know they're taking 20 milliliters. Milligrams are on the top, so we're going to put 125 on the top over 5 ml. 20 over here to cancel these two out. 20 up here. We're going to multiply those, and that gives us 500 milligrams. Now you can move the decimal to grams. 1, 2, 3 milligrams to grams is 3 spaces away from the decimal, so we're going to take 0.5 grams every day. Now, looking at D, using the following drug label, how many bottles of Biaxin will be needed to fill this prescription? Now, you have to kind of get used to looking at these prescription labels. If you look at the very top where it says NDC, right under there it says that there are 100 milliliters in each bottle. Now, if we're taking 140, one bottle is not going to be enough. You're going to need 2 bottles. And 2 bottles is going to be 200 mils, so you're actually going to have some left over. So a lot of times when you're looking at the directions, in this case it doesn't say it, but a lot of times it's going to say take 2 teaspoons full twice a day with food for 7 days, and then discard remainder. This one doesn't say it, but you'll see that a lot as you type them into the pharmacy. All right, let's look at number 42. A patient is to take 1.5 grams of amoxicillin prior to a dental procedure. The capsules available are shown in the following label. They're shown as 250 milligrams. How many capsules will be dispensed? So that's what we're going to find. But first we need to find out grams to milligrams. And you can just very quickly convert this by moving the decimal 3. So that's going to be 1,500 milligrams. And if we know they come 250 milligrams per capsule, we're going to divide that. And that is going to give us 6 capsules. Now you can still set up your proportion if you like, if that makes you feel more comfortable. You can always do it that way. X milligrams over 1.5 grams, 1,000 milligrams per gram, and you can solve for X that way. It's really just a personal preference. All right, let's look at the last one, number 43. A patient is to receive 1,000 milligrams of vancomycin twice a day. Diluted in IV solution. The following label shows the stock available. If you take a close look, it says that it's equivalent to 5 grams of vancomycin. So, first thing we're going to want to do is take a look. The first question is how many doses are available in one vial? Well, if 1,000 milligrams, we know we can convert this to grams. 1, 2, 3, we know that this is equal to 1 gram. And if there are 5 grams in a vial, we'll know that there are 5 doses available. Now, question B asks how many days will one vial last? Well, we can set up a proportion for that. We're looking for days. And we know that there are 5 doses in the vial. And we also know that every day the patient is taking 2 doses. So we take this times 5 doses. This cancels out, and we do the same over here. The doses cancel out. 5 divided by 2, and that vial is going to last us 2.5 days. Okay, so go ahead and work out the rest of the problem sets that we did not do together. If you have questions, feel free to post them on the Q&A, and good luck with the rest of the section.